Okay, so this is Unit 2, Lesson 4, Exponent Laws, the first lesson. In class, I have told you that we're going to learn 5 exponent laws. We've learned 2, which we're going to review in the lesson already, and we are going to learn 3 more. So what we're going to do is I may split this lesson up into part 1, part 2, and part 3. I'm going to see how long it takes me in order to get through the first little part here through the first law. So before we can even begin, what we're going to do is we have to review a few things. Okay, so the product is the answer when you multiply two numbers or variables together. So in the example, 2 times 3 is equal to 6. 6 is the product. Actually, I can just leave that out. Quotient is the answer when you divide two numbers. You really have to know those two terms because otherwise you won't understand what I mean by the product law and the quotient law, which is what we're going to investigate today. So the quotient is is the answer when you divide two numbers. So 24 divided by 6 is 4. 4 would be the quotient. This is a really important concept if you haven't figured it out yet, because it was all of lesson 1, and it is the basis to the entire unit, where power is just a short way of writing repeated multiplication. So 3 to the power of 4, instead of writing 3 times 3 times 3 times 3, I can just write 3 to the power of 4. It means the same thing. We have already learned 2 power laws. We've learned that anything raised to the power of 0 is equal to 1. So anything raised to the power is equal to 1. And x cannot equal to 0. Okay? So that is the first. It's called the 0 power. So any base, doesn't matter, positive, negative, fraction, whatever, it's always equal to 1, except that base can equal to 0. And then the identity power is any base, I'm going to represent it by the letter A now, raised to the power of 1 is just itself. Okay? So any base raised to the power of 1 is just itself, is equal to A. And it works vice versa as well. If I have A, I can write it as A to the power of 1. So that's all pretty important stuff in order to do the next little lesson. So what we're going to do here is, and I'm going to just shorten it, I'm having the class go through, turn to page 73. You have 3 dice, and they are going to roll 3 dice, and you're going to come up with, one of the dice is your base, and the other 2 dice will be your exponents. Okay, so I'm actually going to do this for you here, and we're just going to kind of work through the lab together. So I have 3 dice here. It's more 3 keys, but it's okay. So I'm going to have here, and I'm going to roll, and I have 2 as my base, and I'm not writing this. Okay. And I have a 3 here, and I have a 1 here. Okay, so those were the 3 numbers that I rolled on my dice, on my fake dice. Okay. Actually, I could probably even bring in the other dice, but that's okay, like, because we have dice on the smart board, but that's okay. For all intents and purposes, they're going to be rolling dice. 1 dice indicates the base, and the 2 other dice indicate the exponents. So if I take this, and it's the product of powers. So basically what I'm going to do is I'm going to multiply these 2 powers together. Okay, so I'm going to have 2 times 2 times 2. That is represented by the power 2 to the power of 3. Now that thing is multiplied by the power of 2 to the 1. So it's another way of writing 2 to the power of 1 is 2. So instead of writing them as 2 separate powers, I can actually write it as 1 power. Okay? So this is another way of saying 2 to the power of 4. Okay, so pretend I roll my dice again. Whoops, I'm going to just keep it as this. So say I roll 4 as my base, and one of my exponents is 2, and the other exponent is 5. Okay, so I just rolled my 3 dice. I got a 4 as my base. That's what I rolled. I got 2 as a power, 2 is one of my exponents, and 5 is one of my exponents. So I'm just going to switch to typings because it's a little bit easier for me to, or it's a little bit faster. So 4 to the power of 2 can be written as 4 times 4 in repeated multiplication. Now I'm multiplying that by my other power, and I'm just going to keep brackets around it so you can see which power I'm talking about, because I have 2 of them. So I have 4 to the power of 2, which is this power, or that's repeated multiplication, and 4 to the power of 5, it can be written like that as well. Now again, that is it's tedious to write that. So now if I am multiplying these two powers together, how many am I multiplying, or can I write this as a power? Well, 1, 2, 3, 4, 5, 6, 7. So now I have 4 to the power of 7. So I just wrote 2 powers as 1 power. Let's see if it works again. Pretend I'm rolling my dice, and I get 5 to the power of 3 times 5 to the power of 6. So I rolled my dice and I got 5 as my base, and 3 as one of my exponents, and 6 as my other exponent. I'm just going to switch over to my typing so I can write a little faster. So 5 to the power of 3 is 5 times 5 times 5. And I'm going to multiply it by my second power, which is 5 to the power of 6 is 5 times 5 times 5 times 5 times 5. One more time. I'm going to close that bracket just so that you can see the powers. Okay, so this right here is 5 to the power of 3. This right here is 5 to the power of 6. So if I want to write this whole thing as a power, I'm going to write it as 5 to the power of 9, because there's 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we should be able to start getting a rule here. I got 2 to the power of 3 times 2 to the power of 1, I get 2 to the power of 4. 4 to the power of 2 times 4 to the power of 5 is 4 to the power of 7. 5 to the power of 3 times 5 to the power of 6 is 5 to the power of 9. So I'm going to pause here, or I want you to press pause in the video and describe what the pattern in your table indicates. And then use your pattern to describe a way to multiply 2 powers with the same base. So pause it now. Okay, so what I'm hoping that you guys saw was that we added the exponents. Okay, so bases are the same. We can add the exponents. Okay, I think the bases need to be the same. So let's go on to the real law. That's something that I should have seen written as you guys were working on this investigation. Here are your actual class notes. So instead of writing product of powers with the same base in repeated multiplication, we can shorten the process by adding the exponents. Now, it is a big pain in the butt to have to write this entire thing. I'm just going to change it to a highlighter. Can you imagine? I don't want to, whoops. Oh dear. Okay, let me change it to my highlighter. It would be a pain to actually have to write that every single time. When I know that there's a pattern, I don't want to write that anymore. I can just actually add my exponents. I have 3, I have 1, I add them together, I get 4. I don't change my basis, but I just add my exponents. Okay, so my law is if I have the same bases have to be the same, and I have exponents can be the same, or it doesn't really matter. But all I really have to do is if I'm multiplying, and it's really important that it's product. You're multiplying these two. You can't add, you can't divide, you can't subtract. It only works for multiplication. Then all you do is add the exponents. X can equal to 0 as well. Okay. Oh, actually, yes, x can be equal to 0 in this case. Sorry. Okay. So now what we're going to do is we're going to go over here and we're going to start practicing a few. Okay, so your class example, you have 5 to the power of 3 times 5 to the power of 4, and we want to write it as a single power instead of its repeated multiplication, so we can use that power or product law in order to help us out and write it as a single power. So 5 to the power of 3 can be written as 5 times 5 times 5. 5 to the power of 4 can be written as 5 times 5 times 5 times 5. Now, if I count them all up, 1, 2, 3, 4, 5, 6, 7, I have 5 to the power of 7 because I am multiplying the two powers together. Another way I can write it, instead of having to write out repeated multiplication, I can just say, because it's the same base, I'm multiplying the two powers together, I can just add the exponents. So 5 to the power of 7. Same thing. In class example number 2, I can multiply 3 powers together. As long as, and this is going back to the definition of what a power is. A power is a short way of writing repeated multiplication. So here is 2 to the power of 7. Here is 2 to the power of 3. Here is 2 to the power of 3. I'm multiplying them all together. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, how did I get 14? I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's why. I have an extra one in here. Darn it. Okay, so there should be 7 there. Sorry about that. So there should be 7 there. So I get 2 to the power of 13. Now, again, instead of writing this whole thing out, I can just say 2 is never going to change. And I can go 7 plus 3 plus 3, and I get 2 to the power of 13. Now, if you still have to write it out as repeated multiplication to make sure you get the right answer, do it. Okay? But if you can start using the short form and using those product laws, then again, I don't care how you get to the answer, just get it right. So let's try this one. So now I have a negative base. So negative 2, the brackets indicate that the negative is part of the base. I have it 5 times. 1, 2, 3, 4, 5. Negative 2 is actually negative 2 to the power of 1. Remember the identity power. So I have one more here. So I have negative 2 to the 6. Or I can write it as negative 2, 5 plus 1, negative 2 to the power of 6. You need to make sure you still have those brackets around though. Okay. Now, can I multiply powers that have different bases? No, you can't write those as, you can't use the product law. You cannot write as a single power. The bases are different. It cannot be written as a single power. Okay. So let's just do a quick check here, and that'll be the end of part 1. So just pause this video, try these on your own, and then I'll put up the answers, and then press play, and the answers will be up for you. Okay, so 1 plus 12, powers are, sorry, you're multiplying two powers. Your bases are the same, so I can go to my power or my product law, and I have 4 to the 13. I have 11, which is my base. Bases are the same. I'm multiplying powers. Again, it's really important that they're multiplying powers and not adding or subtracting. So I can use the product law. 12 plus 7 is 19, so it's 11 to the power of 19. So this one would be 49. I'm going to skip a step because I think you guys get it. So I have two powers. I'm multiplying the two powers together. The bases are the same. I can add the exponents. Same thing here. I'm multiplying two powers. Bases are the same. I add the two exponents. Make sure that your negative is in brackets. Here, I'm going to put that exponent in just so I don't forget. Multiplying two powers, bases are the same. I add the exponents. And your bases can be decimals. So bases are the same. I'm multiplying two powers. I add the exponents. Whoops. 2 to the power 2 decimal 3 to the power of 11. Okay, so I am pretty sure that that will probably take me an entire class to do, especially with the math lab. So I'm going to stop here and just check in for part 2.